let us discuss another problem on basic electrical circuits. So the question is, they have given the circuit and A11, A12, A21, A22 and V1, V2 that is equal to I1, I2. So what will be like A11? It is nothing but 1 divided by R, right? So which is nothing but V1 by I1 where I2 is equal to 0. So first let us form the nodal equation and you can see V2 is equal to 6Ix plus V1. Okay, because current is moving direction, so V1 minus V2 is equal to minus 6Ix. And I need to form the what is the current Ix. So for that one you have to apply the nodal voltage method at V1. So you have to remove this dependent source between the V1 and V2. Okay, so I can write this is outgoing current, this is incoming current. So I can write 7 is equal to it. Okay, so since the incoming current is equal to outgoing current, once if you remove 7 is equal to 7 plus V2 by 5 plus V2 by 2 is equal to Ix. Because you can see the thing current is outgoing current and Ix is incoming current towards V1. So I can write Ix is equal to minus V1 divided by 10. Okay. So the current is flowing from the ground to V1 and the resistance is 10 across the that is flowing through the Ix. So I can write 7 plus 0.7 V2 is equal to Ix. Okay. So this is a capital Ix. Okay. So we know the formula for Ix, right? So you just substitute the value. So V2 is equal to minus 6 into Ix value is minus V1 divided by 10 minus V1. So I can bring it like here. So V1 minus V2 is equal to this one. So it is 0.6 V1 minus V2. So I can write 1 minus 0.6 is 0.4 V1 minus V2 is equal to 0. Right? So let me come to the applying the nodal analysis of P1. So this is equal to minus 0.1 V1. Okay. So I can write minus 0.1 or 0.1 V1 plus 0.7 V2, that is equal to minus 7. So this is your A11 and this is your A12 and this is your I1. Okay. In the similar way I can write from this equation, right? This is nothing but 0.4 V1 minus V2 is equal to 0, right? So this is your A21 and this is your A22 and this is your I2. So overall A1 value is 0.1, A12 value is 0.7 and I1 value is minus 7. So you can interchange the signal according sign accordingly. A21 is equal to 0.4, A22 is equal to minus 1 and I1 is minus 7 and I2 is 0. So let us go for another problem. So this is your sixth problem. Okay, so here also you have to apply the nodal voltage method. One at V1, another one at V2 and another one at P3. Okay, so this is 6. Okay, it is not minus 6. So 6 is equal to V1 by 4 plus V1 minus V2 by 3 plus V1 minus V3. Because you can see I should not and do like this. So V1 minus V3 by 6 and plus 3 plus 4. Okay. So you have to write it as 2. Okay. 2 is equal to, if I take V1 common, I will get 1 plus 4 plus 1 plus 3 plus 1 plus 6 plus V minus V2 into 1 by 3 minus 1 by 6 into V3. So on solving, you will get 0.75 V1 minus 0.33 V2 minus 0.166 V3. So this is first equation, and with respect to mode V1, so I can write it as A11, this is your A12, and this value is A13. Okay. So let us go for the load voltage 2. So you have to write this is 622. Now let me go for load voltage V2. So I'm solving the load voltage V2. So V2 divided by 6 plus V2 minus V3 divided by 5 plus V2 minus V1 divided by 3 is equal to 0. So minus 1.3 1 divided by 3 V1 plus 1 by 6 plus 1 by 5 plus 1 by 3 into V2 minus 0.2 V3 is equal to 0. So I can write minus 0.33 V1 plus 0.2 plus 0.33 plus 0. Plus 0.166 V2 minus 0.2 V3 is equal to 0. So this is your A21, this is your A22, and this is your A23. So A21 value already given. So find out the A22 value and A23 value. So next for the node voltage 3, V3 by 8 plus V3 minus V2 divided by 5 plus V3 minus V1 divided by 6 minus 4 is equal to 0. So if I take minus V1 common, so I'll get 1 divided by 6, which is nothing but 0.166 minus 0.2 V2 plus 1 divided by 8 plus 1 divided by 5 plus 1 divided by 6 V3 is equal to 4. So now solving, I will get A31 is equal to minus 0.166, A32 is equal to minus 0.2, A33 is equal to 0.2 plus 0.166 plus 0.125, that is equal to 0.491, and I1 and I2 and I3 values this one. Now let us solve the next equation. So in the circuit, it is shown that what is the power delivered by the 10 volt 1 amps and 2 amp sources. So the answer is, the power length is, I have taken it as 0, 9 watts and 26 watts. So and I am going to read out the circuit like this. Okay. So at the center point, you see both the current are coming inside, 1 amps and 2 amps. So the current flowing through the 1 ohm resistor is 3 amps. Okay. So if Vx is a center point, I can write Vx is equal to 3 volt plus 10. So Vx is 13 volt. So if Vx is 13 volt, okay, and below the point is 0, so P 13 into 2 is 26 watts is like the current that is flowing, power that is generated, delivered by the 26 2 amps current. Okay, next so if I take this voltage as VB minus 10 divided by 2 plus VB divided by 2 plus 1 is equal to 0. So 0.5 VB plus 0.5 VB minus 5 plus 1 is equal to 0. So that VB value is equal to 4. So if VB value is 4 volt and this is 13 volt, what is voltage at this point? It is nothing but minus 9 volt, right? So I can write this is 9 into 1 amps is 9 watt. Okay. So since the current flowing to this one is 0, so I can write that power generated by the 10 volt is 10 volt is 0. So therefore the power generated is cos that 10 volt is 0.